Alright, this first passage deals with looking at light intensity and average air temperatures in a greenhouse that was trying to grow food for a hypothetical long space voyage. Right away you can see that section 1 has significantly higher average light intensities than section 2 or 3, and then in table 2 the weekly average air temperatures are pretty roughly the same. You got 18 to 21. So if we look at the first question here, suppose the efficiency of illumination is defined as the intensity of light absorbed by the plants divided by the intensity of light provided to the plants. Okay, so I see that you wrote a little note there in the equation, which is good, and then it's almost like they tricked you into thinking plants were part of this. But if you go back to the data, there were no plants involved in their experiment whatsoever. So based on that, you're not going to get your absorption variable there. So that means you're not going to be able to get your efficiency here. So it's almost like they tricked you into thinking there were plants because the experiment was about a greenhouse, light intensity, and so forth, but there actually were no plants involved, so you're not going to be able to know that absorption. Alright, so in this experiment here, we are using a syringe to gather exhaust from various cars. And we're also looking at that exhaust at different temperatures. So you got older cars, newer cars, and different temperatures. You can see your newer cars, the percent of carbon monoxide is less. And that is also true with the colder temperature. So the first question they're going to ask here, well, the one you missed actually, is asking about if your syringe contents were contaminated with carbon monoxide free air. And so what I actually thought about when I saw this was, imagine you had a syringe that basically already had some amount of air in it, and then when you pulled the plunger back to get more air in it, so you basically have a total volume that includes some contamination. Now it may not actually be at this position, and this is your actual sample. You can see that it's going to make your overall percent of carbon monoxide less because the contamination made your total volume more. Okay, so if we look at the actual question, okay, what would that contamination do? That's going to make the actual percents would be lower in both those situations. And again, that's because you've got an increase in your total volume. So that sample would be a less percent overall on that. Alright, and that's going to bring us to a vapor pressure